Start recording. Okay, I think I've started. Right. Okay, so we have another couple of subtopics left of this new material, different types of rates, and loan amortization tables. Okay, so that will take perhaps over half an hour. Then we'll disconnect again because only 1 hour is given for free Google Meets users. Okay, and after that we'll connect again after a short break for all your questions about tests of all of the previous tests. Okay, so let's go into the new materials. Let's see.
Excuse me, Professor?
Yeah.
Do we have a quiz this week?
Yes, we also have a test for this new material today. Yep. The quiz is not on Moodle yet. I will post it on Moodle just after our class. And I will give you a lot of time. Maybe 4 p.m. should be okay, right? Is anybody busy all the way until 4 p.m.?
No, because we have midterm exam right after this
Right,
class.
I see.
And could you please extend the deadline a little
Sure,
bit?
yes. Okay, let's say 7 p.m. Sounds okay, right?
7. Yes, I think it's okay.
Jenny, I don't see your camera on. Okay.
And
Professor,
last week,
my connection is...
I couldn't hear that. Did you say camera doesn't work? I couldn't hear that. If the camera doesn't work, then it's okay, of course. Andy, you were asking?
Yeah, last week I asked you, could you please upload the explanation video of last week's test?
That's right, yes. But instead of, I was planning to do that over the next couple of days, as I said at the very beginning of the class today. But there were suggestions, and maybe it's even better we just go through the tests together right now, after we finish the new material. So we finish the new material, then we'll go for another break, and for the third part of the class, we'll go through tests number 4, 5, 6, 7. Yes. Okay, so we're gonna do it together now. Not right now, but after the next break.
Would you provide us practice question for midterm exam?
I will try, but probably not. I will try to find some test banks from some of the older textbooks with, if I can find something, there could be like 100, 200 questions I could upload. Maybe you can practice with that, yes. But I'll try to look at that. I cannot promise it. Perhaps I will not find anything.
Thank you.
I'll try.
Thank you.
And if you have a textbook, I guess not many of you have a textbook. Because I post all materials on Moodle anyway. If you don't have a textbook, you still should be fine. If you have a book, at the end of every chapter, the book has like 20 or 30 problems. So if you have a look at those, that's the sort of questions you will have on the exam. Okay. Anything else before we jump in? Let's go. So start sharing a window. Where is that window? This one. Okay. Oh, and unpin myself. Make myself smaller. How does that? All right. So you guys see the Excel in front of you, and it's pretty big. You don't see my face as too big, no? Okay, good. Okay, as I mentioned, 2 subtopics left for us for today. And those are different types of rates. Okay, this is going to be quite interesting. I like this subtopic. Let me give you one example. One example of two choices of investments. Choice A. Okay, your investment. Let me even zoom in a little. Oh, okay, your investment grows once a month at the rate of, let's say, 1%. Okay. And choice B, your investment grows once a year at the rate of, say, 12.6%. 12.6%. Okay. Okay, let me ask you guys, jump back by a second. Two options. Option A, growing your investment 1% per year. Option B, growing your investment by 12.6%. I'm sorry. Option A, growing your investment by 1% per month. Or option B, growing your investment by 12.6% per year. Which option would you choose? A, B, anybody just shout out, let me hear how many A's, how many B's we have. A, B, just say something.
B.
A.
B, mostly B's, and only if you're A. Very interesting. Actually, let's have a look. What we need to look at to answer this question is taking into account interest on interest every month. How much is the annual interest? So I can compare annual with annual, not comparing monthly with annual. So I can compare apples with apples, not apples with oranges. Okay? So let me go back to chat over here. Choice. Would you choose? Choose choice A for your investment to grow once a month, every month, where your investment of the new value of your investment only happens once a year, but it's growing at 12.6%. Okay, which rate would you guys choose? In choice A, within 1 year, you will have a lot of chance to earn interest on interest, whereas in choice B, within 1 year, there is no chance to earn interest on interest, right? So it's hard to compare these two numbers, right? Which shows us the difference between different types of rates, okay? So to compare the rates, let me see how much exactly I'm going to earn in 1 year with choice A, okay? So the amount I'm going to earn is, of course, going to be 1.01, right, into the power of 12 within a year, right? And then minus 1. So that's actually, if I convert that to percentages, where's percentages here? That's actually 12.68% rather than 12.6% for choice B, which is only growing once a year at this 12.6%. So choice A is better. If you chose B, it's fine because they're very, 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 very close. Choice A and B, 12.68% or 12.6%, very close. Intuitively, without doing calculations, it's very hard to choose the correct one. But actually choice A is a little bit better, right? So you see the difference here? Choice A has more chance to give you interest on interest. So even though it looks like it's smaller than 12.6% because 1% multiplied by 12 is only 12, it's actually going to give you better investment option, 12.68% rather than 12.6%, right? So here's an example that emphasizes, that shows clearly the difference between interest rates, okay? So if you just simply take 1% and multiply by 12, so just take this 1%, multiply it by 12, what you get is 12%. And This kind of calculation has a name. It's called annual percentage rate or annual percentage yield. Different textbooks give you different name, okay? So annual percentage rate or yield, remember yield is another word for rate as well, for interest rate, right? Is simply multiplication of rate per period times number of periods in a year, right? But it doesn't always show the actual return, the actual profit you're going to get from the investment. Like in our choice A example, you're actually going to earn 12.68% effectively in reality, although the APR is only 12%. The APR for choice B is 12.6%. So it looks like choice B is better because APR is better. But instead of looking at APR, for the actual amount that you're going to earn, for the effective amount you're going to earn, we need to look at the actual money, right? So there's that other kind of interest rate, which is called effective annual rate. So easy to remember from the word, from the name of it. Which is the actual rate you are earning, and effective is just another word for actual, so it's easy to remember. The effective rate you are earning based on interest, and it's also per year, so it's effective annual rate. You are earning per year based on interest, right? So the formula for EAR is kind of, as you see, kind of tricky. We have this formula over here. It's 1 plus that rate per period into the power of number of periods in a year minus 1. But it's okay, you don't have to remember that formula. Okay, we have Excel for us, so it's going to help us. So let's have a look at this example. Let's say choice C. Oh, and the standard for the industry convention that we have mentioned over the last 1 or 2 hours is the APR, APY. Okay, and let's turn it into red, and this is the industry standard, because it's kind of easy to understand this one, and to avoid any kind of confusion. In most countries of the world, whenever the banks or the credit card companies or any kind of other investment companies advertise any rates, they must advertise APR or they must advertise APY, not any kind of other rates. Okay, so there it is. So let's say we have an advertisement for 2 more investment choices. Choice C, okay, APR of let's say 15.8% with quarterly compounding, okay, which means the investment is growing every quarter, okay. And choice D, APR of let's say only 13.8% with daily, oh my god, compounding, oh my god, daily compounding. Which option would you choose? To answer this question, you don't just simply compare APR or APY because they're on different compounding. One is quarterly, one is daily. You actually need to compare effective annual rate. That's going to actually show you the effective amount of money that choice C or choice B is going to profit for you. Okay, so let's calculate effective rates from these examples. And the Excel formula here is equals effect, very easy. Equals effect, open the brackets, and what do we see? The nominal rate. For Excel, the nominal rate is the APR. That's what Excel calls the APR. APY, APR in Excel is called nominal rate. Okay, so that's just 0.158, comma, and NPRY. NPERY is not NPR. Over here we had NPR. NPR is number of periods in your whole investment life, right? But NPRY, it's a bit different. There is one extra Y over here. That means how many periods are inside 1 year only. How many periods are inside 1 year only? So if you look at quarterly periods, there are 4 periods in 1 year. So choice C gives you an effective annual rate of 16.76%. How about choice D? So again, equals effect, open the brackets, and nominal is 13.8, so 0.138. Here we have daily compounding. So NPRY in 1 year, how many days? 365. Close the brackets, hit enter. Well, yeah, here choice D is still smaller. Let me change the numbers a little bit to make it kind of more of an illustrative example. Okay, let's change it to 14%. And we're going to change this to 14%. So again, it's a better example because it looks like choice C is better. It's going to give me 14% versus 13.8% APR as advertised. Because remember, industry standard in any kind of advertisements is APR, right? But if you look at the actual effective rate, because choice D gives you more chance of interest on interest, it's going to give you more effective annual rate of 14.795% rather than 14.75%. Okay, so that's the Excel formula to calculate effective rate equals effect. NPRY is number of periods inside 1 year only. Okay, so let's type it out so it's clear. NPERY is not the same as NPR. Okay, NPRY is the number of periods in a year. Okay, in a year. And let's have a look at another example so that we learn how to calculate APR using Excel formulas. Okay. An investment with monthly compounding pays, let's say 1.2% per month. How much is APR? Okay, that's one example. Second example is you would like to earn an effective annual rate of, let's say, 15%. How much APR you should look for in investment advertisements with, let's say, monthly compounding. Okay. So first question is really easy. Per month, you get 1.2%. To calculate APR, scroll up a little, we simply multiply by the number of periods in a year. Okay, if you already know the interest rate per small period, just multiply it by the number of these small periods in a year to find APR. So the answer to the first question, right, is simply 1.2% times 12, which gives you equals 0012 times 12, 14.4% APR, annual percentage rate. Okay, in the second example, I don't know the actual rate per month. I just know that I really want to earn 15% per year in reality, effectively. But if I look for some sort of investment advertisements, they're not going to show effective annual rate, they're going to show APR. So what's that APR I should target in my search? Let's see, answer is going to be equals nominal. Okay, so Excel calls APR nominal, equals nominal, open the brackets, effective rate 0.15, and I'm looking at monthly compounding, so that's NPRY of 12. So any advertisement of 15.06% with monthly compounding will actually earn me, in reality, 15% per year. Okay? So that's the subtopic of the different types of rates. The two types of rates we learned are APR or APY and the EAR, effective annual rate. Okay? So, good question. So the question is, if you didn't hear the question, is effective annual rate always bigger than annual percentage rate? Almost always. The only time, okay, EAR is almost always bigger than APR for the same investment. The only time when EAR equals APR is when the compounding is annual. Okay? So when the compounding is annual, when the investment only grows one time per year, okay, the effective annual rate doesn't have any chance to give you interest on interest inside within 1 year. So in that case, EAR is going to be equal to APR. But EAR is never smaller than APR. So EAR is never smaller than APR. EAR is either bigger or equal to APR. Okay. So let's have a look at an example. Let's say annual compounding. APR is say 8.9%. How much is effective annual rate? So equals effect, open the brackets. The nominal rate is 0.089 and there is only one period within 1 year. So it's annual compounding. As you see, effective annual rate is the same as APR. That's the only time when they are the same. In any other times when compounding is less than per year, effective annual rate is going to be bigger than APR. It's never smaller than APR. Our last subtopic is loan amortization table. Okay, this is kind of tedious, quite detailed, but I hope I managed to explain it clearly. Okay, so loan amortization table is a big table that shows you how you progress with repaying the loan. Let's have a look at an example. Say you borrow 5 million from a bank to buy an apartment, right? Say the bank charges you, let's say 3.6%. I don't say anything about the rates, so that's APR, okay? Your mortgage repayments are monthly, okay? And you borrow for, let's say, 15 years, okay? Let's have a couple of questions here. This table is going to be huge. That's 15 times 12. That's many rows. Let's say you just borrow for 5 years, okay? Make a loan amortization table and how much you still owe to the bank after, let's say, 3 years. These two questions. So let's make a table. What does the table consist of? It starts with the beginning balance. It goes on to the regular payments. Let's look at interest, then regular payments, and the ending balance. There it is. And we have periods over here. So the first month and second month and third month and fourth month, how many months do we have? 12 times 5 is 60. Oh my god, it's going to be a big table. Let's zoom out a little bit. We can still manage. The computer is going to do a lot of calculations for us, so that's fine. 60. 60 is too far. Let's make it a smaller loan over a shorter period of time. Let's say you borrow just 2 million. And let's say you borrow for only 3 years. So 3 times 12 is going to be 36 lines. That's kind of a little bit better. Okay. There. So at the beginning of the first month, right, how much do you owe to the bank? At the beginning of the very first month, that's the time where you got the 2 million. So the starting amount over here, okay. During the first month, how much is the interest that the bank is going to charge you? Well, they're going to charge you 3.6% per year. So per month is going to be divided by 12 times the amount of money. Okay, so the interest that accumulates on top of what you owe to the bank by the end of the first month is going to be 6,000 extra. Okay, now how about the PMT? We need to calculate equals PMT. That's your regular payments to repay the mortgage in 3 years. So that equals PMT, open the brackets. The rate is 0036 divided by 12. Number of periods is you're going to pay it in 3 years times 12 because we need to match everything to the smallest period, which is a month. The PV right now you're gonna get 2 million from the bank. That's a positive number. You're gonna get it right now, right? And FV by the end of 36 months, once you finish with your regular payments, is there going to be anything else to pay to the bank? Hopefully not. So FV is going to be 0. Okay. Ignore the type, it's a regular annuity because you're going to pay at the end of every month. There, you're going to pay a PMT of over 58,000 every month. Let me make it negative. So negative kills the number, the negative here. I just want to have everything positive in this table. It's easier to work with numbers then for me. An ending balance. So at the beginning of the first month, which is the day you get the 2 million from the bank, you owe the bank 2 million. Over the next 4 weeks, over the next month, some interest accumulates, another 6,000. So by the end of the first month, you owe the bank 2 million and 6,000. But on the last day of the month, you're going to pay the bank more than 58,000. So you're going to owe less to the bank by the end of the first month, right? So this is going to be the original amount that you owe to the bank at the beginning of this period, plus the interest that accumulates during this period, minus what you pay to the bank at the end of this period. Bum. What is this? I already told you when you see something like this on the computer, it's not a big deal. It means there is no space to show the number. Just give it a bit more space. You will owe to the bank 1,947,000. You will owe to the bank more than 1,947,000. Okay, so that's the last day of the first month. On the first day of the second month, how much do you owe to the bank? Well, it's the same. The last day of the first month is more or less the same as the first day of the next month. So I just hit equals and this amount, enter. Okay, this is what we need to do for the amortization table. The rest is just calculated by the computer. Okay, double click here, then select these and double click. Something is working here. Something is wrong because, as you know, by the end of the loan life, I should owe nothing to the bank. So if you've done the calculations correctly, you can automatically check your calculations. This ending balance by the end of the last month should be 0. You don't owe anything else to the bank. So let's see what's happening here. Okay. So this amount over here should keep decreasing, but it doesn't. The reason it doesn't decrease is because when I copied it, I selected both of these cells and double-clicked. So as you see, 2 million, 2 million and 1, 2 million and 2, the computer automatically adds 1 every time. So, okay, instead we should select one cell and double click here. It's zeros for now, no problem. Just select these 3 cells and double click. Bam! Everything is working, I think. There. Yes, it's 0. Now everything is correct. So even if this table is really big for 15 years, that's still fine. You just need to fill out the first period and the beginning balance of the second period. Okay. So this is the first task completed. We've done the amortization table. Now the second task is how much you still owe to the bank at the end of 3 years. Let's change this question because the loan life is 3 years and how much you owe to the bank at the end of 3 years. Of course, you owe him 0. So let's change the question at the end of 2 years. 2 years is 24 months. So at the end of month 24, at the end, you still owe to the bank $690,779.1. Okay, so the answer here equals the ending balance after 24 months. Enter. That's the answer. So that's how we create amortization tables, and that's how we answer questions about this amortization table. Okay. For example, another question could be, how much is the interest that accumulates during the 8th month of the loan, right? Well, 8 months, the interest that accumulates is extra $4,883.44. So the answer here is equal 8 months interest during that time. Over here, enter. Okay, so this is the last subtopic for today's chapter. Remember, back on Moodle, you still have your practice test for today. Okay, I'm back. Pinning myself for large screen. That's the end of today's chapter, end of chapter 5. Okay. Again, next week, midterm, we'll have chapters 2, 3, 4, 5. All right. Let's go for a break, and I'll be back in 10 minutes. Again, let's disconnect completely because we only have 1 hour in Google. I'll post another link on Moodle for our third part of the class, where we'll go through the tests numbers 4, 5, 6, 7. The first 3 tests, the answers to those are already on Moodle. Okay, see you soon.